Hi, Professor Caps. So today we're going to talk about ferrofluid. A couple of things starting out. So I did the experiment, but since I'm in Mexico right now, I had to go off of the list of supplies that you had posted at the beginning of the semester, which in that list it only said ink toner and vegetable oil and magnet. I got all of those, but it ended up being the wrong kind of ink toner. It needed to be the specifically like laser ink toner. Obviously, because of what I'm about to talk about, the ingredients in that kind of ink toner is different than just like normal ink toner. So then also I got the wrong kind of magnets. I didn't know it needed to be a rare earth magnet, a really powerful one. I literally just got like a tiny little like normal magnet. So here is my supplies, and as you can see, I put the oil and the ink in the cup and everything, and it did not work as planned. But I watched a ton of videos to learn about it, and it was super cool, and I wish it would have worked. So that is that. Also, just like I guess a suggestion, feedback is maybe in that list. I'm probably the only one that ran into this issue, but maybe in that list of ingredients needed, maybe a little bit more of a detailed list of ingredients to say like what kind of magnet is needed and exactly what kind of toner is needed would have been helpful, because I would have been able to get that before I got to Mexico. Now that I'm here, I can't get my hands on any of that. Ferrofluid we'll just jump right in. Ferrofluid is a colloidal suspension of small magnetic particles in fluid. So in this situation, it is the ink toner, which has iron oxide or magnetite in it, that are literally tiny little nanoparticles, and they are magnetic. And the fluid that is used is the vegetable oil to help with the viscosity, I believe. So in a suspension, solid particles are dispersed. The viscosity of the fluid, the tiny size of the particles, and the particles' constant motion keeps the solid from settling out. The magnetic particles in ferrofluid are super tiny. They're around 10 nanometers. At least that's what I'm reading online. That's the size of the particles in normal ink toner. And let's see, so basically the solution acts as a liquid when there's no magnetic pull from a magnet around it. It acts as a liquid. But when there is a magnet, it forms into what appears to be a solid state. There is no like reaction occurring to change it from liquid to solid. It just appears to be solid. And so I was also just like learning and researching and found that ferrofluid is super paramagnetic, which can only be found, a property that can only be found at the nanoscale, which basically means they become paramagnetic. They only behave like magnets in the presence of a magnetic field. So, let me see if there's anything else. Ferrofluid can be used in a ton of different ways. Sometimes it's used in MRIs as a contrast agent. It can be used to carry certain medications to specific locations of the body. It can also be used in hard drives of computers and other rotating shaft motors. Some loudspeakers use ferrofluid to dampen vibrations. What else? I don't know if I explained this well. So, yeah, I think that's it. I'm reading over my notes. Basically, the particles that are suspended in the vegetable oil are temporarily magnetized and form tiny little structures in the fluid. Um, and then when the magnet is removed, the particles are demagnetized and the ferrofluid acts like a liquid again. So I think that's all. I'm over 5 minutes now. I think that's everything. I hope you have a great day.